Hi, I'm Rick Jones. Today we will review the final updates for version 3.06. First, I'm proud to announce that Induction Logic Pro engine analysis and camshaft design software is now officially endorsed by Darin and Chad Speier. Both experts agree that our software is highly educational for all experience levels and strongly recommended to everyone. Now let's get to the software. This is the calibration form. It calibrates your port flow bench with our port flow bench. This is the new valve to piston clearance form. Should be self-explanatory. This is the profile generation form. We've added push buttons for the cam journal diameter, asymmetrical intake generation, and adjustments for the seat duration, the lobe lift, and the profile area. You can now do your own cams on both intake and exhaust and generate the profiles. Additions to the graph form. We've added the lag time. We've added intake cross-sectional area velocity graphs, minimum cross-sectional area velocity graphs, and the throat velocity graphs. We also added the demand RPM button. It allows you to raise the RPM just on the graph screen to check the port velocities at horsepower RPM and going out the back door at max RPM. And I think that's about it. All right, we're going to get to the last update. Customers have recently shared their confusion regarding the dynamic compression ratio. The confusion stems from the fact that there are three different answers to the single question, what is your dynamic compression ratio? The deciding factor in this calculation is the intake valve closing, which should be simple to determine. While using the valve seat duration tells you exactly when the valve mechanically closes, some experts argue that cylinder pressure overcomes the intake port charge column before total closure occurs. As a result, they calculate the intake valve closing point using either 20 thousandths or 50 thousandths valve lift duration instead. Each of these calculation methods results in vastly different dynamic compression ratio values. Furthermore, each method requires its own acceptable target range based on the fuel octane, cylinder head material, and combustion chamber design. To keep myself out of this ongoing debate, I added a new text label, a message box, and a few lines of code to the software. Users can now calculate the dynamic compression ratio using all three duration values. This gives them the flexibility to manipulate the intake profile until it satisfies any single calculation method or all three at once. To eliminate any unnecessary debate over the final camshaft configuration, the software removes design choices from the equation entirely. Before you begin manipulating the intake profile via the cam design velocity, the program automatically preloads all relevant exhaust data and short block variables onto a master print form. Once you achieve your target DCR values, simply select yes at the print cam values prompt. The system instantly compiles the complete dataset, appending your new intake profile, adjusted design velocity, and the selected DCR values and calculation methods to the document. Ultimately, this gives builders a precise tool that improves the odds of delivering a safe, detonation-free engine by 300%. The technical reasoning for leaving the exhaust camshaft profile independent during this process is detailed in the user manual. If you think you know why, please post your answer in the comments. Thank you for watching.